Dear students, now we are solving third question of exercise 1.2. Third question is verify the following properties. Verification means we want to prove that these properties are right in case of addition or subtraction, or in case of four operations or of integers. First question, commutative property of addition of integers. Commutative property. Dear students, you have learned that what is commutative property. This is in addition. So commutative property means when we add two integers, if we change the order of addition of integers, it will not affect the result. So this we want to prove that by this question. Here m plus n property is m plus n is equal to n plus m. Here you can see that order of these integers are changed. So here m is equal to, we are taking any example. M we give -8 and n we give 6. Then we are adding first to this side m plus n. M plus n means, that means m is -8 plus n is 6. One is negative, another is positive. So we subtract. When we subtract, we get a 2, and the integers having greater absolute value is 8. Its symbol is negative, therefore we put -2. And here, this one side we have solved. Next, that is n plus m. Here 6 plus -8. Order of addition is changed. Still here one negative, another positive, we subtract, and symbol is negative. Here you can see that both sides are equal. So we write it as therefore m plus n is equal to n plus m, that's equal to -2, and hence it is verified. Here you can see that both sides, or LHS and RHS, both sides are equal. That means here, even though we change the order of addition of integers, the answer will be same. In this way we have verified this property. Next, one associative property of addition. Associative property says that when we add three integers, a change in the order of grouping will not affect the result. Here we take m plus n plus p is equal to m plus n plus p. Here first two numbers are grouped, here last two numbers are grouped, then added. But we can see that both sides are equal. That we can see with the help of this example. M we have taken 3, n we have taken -5, and p we have taken -12. Then first side we are going to solve m plus n bracket plus p, that's equal to m is 3 plus -5 plus p is -12. So here inside the bracket we solve. Here one is negative, another is positive, we subtract. When we subtract, we get -2 plus -12. Both are negative, therefore we add 12 plus 2 is equal to -14. And next side we solve m plus n plus p. Here m is outside, means 3 plus -5 plus -12. Here m plus -5, -12, both we are adding. We are solving inside the bracket first. Therefore we get a -17. Then here one positive, another negative, we subtract, then we get 14, and bigger numbers symbol is negative, therefore we put -14. Here also we can see both sides are equal, therefore we write m plus n plus p is equal to m plus n plus p, that is equal to -14 and verified. So here we can give any value to the variable. Next we are going to solve associative property of multiplication. Here it is relating to multiplication. Associative property of addition and multiplication, only symbol change, remaining things are same. When we change the order of grouping of three integers in multiplication, it will not affect the result. That's the that we want to prove, want to verify. So here we are going to verify. So here m into n into p, that means negative 2 into 6 into 3. Here we have given different values to each integers, each variable, and then we multiply 2 into 6, 12, and one is negative, another is positive, so negative symbol, and into 3, 12 3s are 36. Again it is negative, one is negative, another is positive numbers, and here we have got negative 36. And let us change the order. Here last two numbers we multiply first, then 6 into 3 18, and here negative 2 into 18 is equal to negative 36. Here also 36. So here we have verified that m into n into p is equal to m into n into p, that is equal to negative 36. Both are negative 36. Hence it is verified that verified. So here we have proved that even though we change the order of multiplication of integers, it will not affect the result. Next, distributive law of multiplication over addition. We have studied distributive property of multiplication over addition and over subtraction. Here we want to prove over addition. M into n into p is equal to m into n plus m into p. This is distributive property of addition. Here we want to assume values to different variable, and then we prove that verify that this law of distributive property of addition of integers. Then here m means it is 6 into n plus n. N is negative 5, n plus p, and p is 3. That will be equal or not equal, that we want to prove. So first one side we will solve this LHS, right? Left hand side we solve. Then after we solve the right hand side, then we prove that both sides are equal. So inside the bracket we solve first. Inside the bracket it is addition, therefore we follow addition rule. One is negative, another is positive, we subtract, then negative 2. Then negative 2 into 6 is equal to negative 12. So one side we have solved, then we got negative 12. Let us see another side. Next side is m into n. M into n means with this m we multiply n, and with this m we multiply p. M into n plus, in between there is plus addition, distributive property of multiplication over addition, therefore plus into m into p. So here m means which one? 6. 6 into n, negative 5, plus 6 into 3. Then 6 5s are 30, negative 30, plus 6 3s are 18. Here again subtraction, one is negative, another is positive, we subtract. 30 minus 18 is equal to 12. As this symbol of bigger number having greater absolute value is negative, therefore we put the negative. So here we proved that this both sides are equal. So therefore we write that m into n plus p is equal to m into n plus m into p, and hence it is verified. That is equal to negative 12, and hence it is equal to hence it is verified. So these are the question 3, distributive property multiplication, and one is not solved. That is homework for you. You can do as yourself.